First, we select the structural type as a chimney. Next, we must select the MWFRS method, and for a chimney, the only valid option is Chapter 29. There is not a component and cladding method for a chimney, and so we select the C&C method as none. A chimney is typically a flexible structure, and so the dynamic type must be specified as flexible, and then the natural frequency must be entered. Ideally, the natural frequency would be calculated using a rigorous dynamic analysis, but if no such analysis is available, then the frequency can be estimated by using the option for cantilevered masts or poles of uniform cross-section. When using this frequency estimator, you enter the parameters and then click Save, and that calculated frequency will be utilized in the calculations. The user must also specify the structural damping. For a steel stack, this value would typically be on the order of 0.002. If you hover over this entry, some typical values can be viewed. Now, to enter the chimney dimensions, we select the Chimney tab. The first entry is to specify whether the flexible gust factor should be used, and typically for a slender chimney, this should always be calculated using the flexible gust factor. If you have a tapered chimney or pole, then you can click the tapered option. We will utilize the tapered option for our example. We enter the tapered parameters on this tapered form. The taper is approximated by a series of step cylinders, as shown in the graphic on the form. We can elect to either match the top diameter or bottom diameter. Typically, the top diameters is used, so we will select that option. Now we click Save, and the series of cylinders is populated in the table. In addition, we can see graphically at the right the chimney that has been modeled. The shape selection is used to determine the shape factor that is used for the wind calculation. If you hover over the entry, you can see additional information on each selection. Here we can also specify if we have shape that is not round, such as a hexagon, octagon, or square. ASCE 7 doesn't have an option for rectangular, and so you would have to use square and create two different files, one for the width in each direction. Finally, we specify any additional wind area that would be added to the structure, such as ladders, platforms, piping, or any other type of attachment. The value specified should include any shape factor that is to be considered. For example, let's say we have a caged ladder extending from 20 feet to grade. The caged ladder has a wind area of 1 square foot every 1 foot of stack length. The ladder is constructed of flat bars and angles, and so we will be using a shape factor of 2. That results in a total wind area of 2 square foot for every foot of stack. To enter this, we specify 2 feet of width, which is the same as indicating 2 square foot per foot of stack. Now we click Perform Analysis and can view the wind load calculations. The force for each element is calculated and then the moment that it creates about grade. Please notice that the total area is larger from 20 to 0 foot, which is where we added the ladder. Now let's go back to the Chimney tab and discuss a couple of alternatives. In our example, we used a tapered stack option. Let's say we have a constant diameter stack. We would like to enter an element every 10 feet because we will get wind pressures at each elevation where we enter a new element break. We could do this manually, or we can use the tapered option to save us some time. Click the tapered option again. Now we specify the top and bottom diameter as 6 feet, and then click Save. Now we see a constant diameter stack with a new element specified every 10 feet. This is much faster than manually entering each of these elements. Now let's assume that our ladder goes from 25 feet to grade, rather than the 20 feet that we previously considered. We don't have an elevation at 25 feet, and it would simplify things if we did have a break at 25 feet. To do this, we click the far left gray area next to the 20 feet elevation. With the row selected, we then click the Insert tool at the bottom. This inserts a new row about our 20-foot elevation. Now we enter 25 feet at this new entry, and then we can add our 2 feet additional width from 25 feet, down to 0 to represent the caged ladder.